right? So today we'll solve some problems based on static friction. If time permits, we'll move on to kinetic friction also. Assume there is a 20 kg block on the ground. Ground, obviously a rough surface. Let's say it has a coefficient of static friction of 0.4. Okay. One of you quickly tell me what is the formula for limiting friction? Formula for limiting friction. You know the factors on which it depends. It depends on the nature of surfaces. Okay. And it depends on the normal force between the surfaces. So what is the formula for limiting friction?
Mu of the surface and then the normal force.
Okay. Mu s multiplied with n. Mu s is called coefficient of static friction. It depends on the nature of surfaces in contact. N is the normal force between them. Okay. So remember, this is the maximum friction that can act between two surfaces. Maximum static friction. Right. So let's say we try to move this block by applying a horizontal force on it. Assume the force is a variable force, time dependent force, something like 2t square. Okay. So depending on the time, the magnitude or the strength of the force increases. Okay. Changes. So the question is, first, at t is equal to 1 second, how much is the friction acting on the block? Then the next question, at what time does the block start sliding? Try this, all of you. I'll give you all 2 minutes. You can type your answers in chat. Okay, I got 2 Newton, 10 seconds, and another answer has 2 Newton and root 40 seconds. Where did square roots come from? Okay, possible. Fine. Rishi, tell me, at t equal to 1 second, why will the friction only be 2 Newtons? You said 2 Newtons.
Here I just substituted 1 into that. I might be wrong.
No, you substitute 1 into that. The applied force, this F is the force with which we are pulling the block.
Yeah,
The,
yes, sir.
at 1 second, the applied force becomes 2 newtons. Why should friction be 2 newtons?
So friction. My bad, sir. One.
Okay, Vanilla, you tell. At 1 second, how do you calculate friction as 2 newtons?
Sir, friction opposes the movement, no, sir. So I thought friction must be 2 Newton.
Okay, correct. Your logic is correct only. Listen, all of you. Friction always tries its best to prevent sliding. That's all. And how much ever effort is necessary to prevent sliding, it will put that much effort only. Now at 1 second, the applied force, substitute T as 1, the applied force becomes 2 newtons. What is that force doing? It is trying to slide the block. Okay. Are there any other forces acting on the block? Yes, there will be weight acting, but it acts vertically downwards, 200 Newton. And there will also be a normal force from the ground acting, and that normal force will be in the upward direction. These two forces, the normal force and the weight of the block, they are acting vertically. They are not, I mean, they will not have any component along the incline, along the horizontal surface, ground. So F is the only force which is trying to make the block slide. So listen, I'm teaching you how to approach questions with friction in them. You should first find out what is trying to make the object slide. Okay, because friction will act only when there is a tendency to slide or if there is already sliding happening. Okay, so you should first check what tries to make this system slide. So you should visualize the forces acting on it. Now weight and normal force being vertical, they are not trying to slide the block horizontally. F is the only force trying to slide it, and its magnitude is 2 newtons at 1 second. Friction wants to prevent sliding. Okay, friction hates sliding, as I told you. Now to prevent the block from sliding at that moment, how much friction is necessary in the opposite direction? 2 Newton would be sufficient, right? Because the force trying to make the block slide is 2 Newton, then you just need 2 newtons to oppose that. So 2 Newton friction would be sufficient. Is this clear to all of you? If you have any questions, you can ask. At t equal to 1 second, sliding force is 2 newtons. Therefore, friction acting will also be 2 newtons. Now I directly said friction acting will be 2 newtons. How do I know if friction can actually become 2 newtons or not? Static friction has a limit. Okay, so this is another point you need to keep in mind when you solve problems based on friction. You can find out how much friction is necessary to prevent sliding. Here, what I have effectively done is that only. 2 Newton friction is needed to prevent sliding at 1 second. Okay, so I should say friction required is 2 Newton. Now I'll need to check if that much friction can be generated or not. Okay, for that we use this, the formula for limiting friction. Now tell me, in this case, how much will the normal force be?
200.
200 newtons. There are no other forces acting vertically. Then normal force has to balance the weight of the block. Okay, so normal force is 200 Newton. This force that we are applying doesn't have a vertical component. It only acts horizontally, so it won't disturb the normal force. See, there are a lot of factors you need to consider while solving problems. Normal is not always equal to mg. Okay, so you have to look at what other forces are acting. Are there any other forces vertically, okay, or perpendicular to the surface? Based on that, you determine how much normal force would be acting. In this case, it is 200 Newton. If normal force is 200 Newton, how much is the limiting friction in this case? Limiting friction, the
80
formula,
Newton.
yeah, the formula is mu s into n, becomes 0.4 into 200, that is 80 Newton. Friction can increase itself up to 80 newtons if necessary. Okay, but at 1 second, the sliding force is only 2 newtons, so friction will also be 2 newtons. We found that the required friction is 2 newtons, and now we check that this much is available. So that is what will act. Friction can increase itself up to 80 newtons, but it won't put more effort than necessary. Okay, it will never act more than necessary. To prevent sliding, 2 newtons is only necessary. That much only will act at 1 second. Okay. The second part of the question, at what time does the block start sliding? Aishwarya, any answer?
Sir, 10 seconds.
Okay, your voice was breaking. Type your answer. Saket, what about you? Any answer for the second part of the question?
No, sir.
Okay, Saket, you tell me, what is trying to slide the block? Which force is trying to slide the block? Okay, anyone?
Sir, the force which is on the right.
The force F is equal to 2t square is what is trying to make the block slide. What is preventing the block from sliding?
Sir, the
Huh?
friction and
Friction and
the normal force.
how do you say a normal force is preventing the block from sliding?
No, like the mass of it. So like until and unless we put a certain force
No.
onto it, it won't move, right?
Why? What is opposing it? Friction only, no? What else will be opposing the motion of the block or sliding?
Yes, sir. Okay.
Okay. Depending on how heavy the block is, or depending on how much normal force it experiences, friction can increase itself, but it's ultimately friction that tries to prevent sliding in this case. Okay. I'm telling this to all of you. So sliding force is 2t square. The force opposing sliding is friction. The question is asking at what time does the block start sliding? So for the block to start sliding, sliding force should become greater than or equal to limiting friction, the maximum extent to which friction can increase. If the sliding force is more than that, then sliding will start. Okay, that means 2t square should be greater than or equal to 80. So this becomes 40. T square more than or equal to 40. That means t should be greater than or equal to root 40, or you can say 2 root 10 seconds. So at t is equal to 2 root 10 seconds, the block starts sliding. Is this clear to all of you? Any doubts in this? The question was about when the block starts sliding. So you have to think what is trying to make the block slide, what is trying to prevent it from sliding. When what is trying to make it slide is stronger than what prevents it from sliding, it will definitely slide. Okay. Now once it starts
Yes.
sliding, yeah, tell me.
So the block, the mass of the block doesn't depend much, right? It's only the mu which depends on like the sliding.
See, for the object to start sliding, what should the sliding force overcome?
To overcome the friction.
Limiting friction. It should overcome the maximum friction. That is the limiting friction. On what factors does limiting friction depend?
Oh yeah, the normal force.
Okay. So their mass matters. Okay.
Okay, sir.
Fine. Let's consider another case. Inclined plane. Just a moment. Okay. Assume the angle is some 37 degrees. Let's say this is a 10 kg block. It is found that the block is in equilibrium. How is it possible for it to be in equilibrium? Should the surface be a rough surface, or will it be in equilibrium even if it's a smooth surface?
Sir, it has to be rough. If it's smooth, it'll just slide down.
It has to be a rough surface. Friction is what can prevent it from sliding. Correct. So first question. Block is in equilibrium and at rest, I should say. Because equilibrium is possible with constant velocity also. So block is at rest. So calculate how much friction is acting on it. And you know if it is at rest, if it's not sliding, it's static friction only. Then based on that, you find out what is the minimum coefficient of friction between the block and the surface such that it can stay there. Okay. Try this, all of you. Calculate how much friction acts on the block and what is the minimum coefficient of friction needed. Any answer, anyone? Okay, I got one answer as 60 and 0.6. We'll see. Okay. See, it's a case of equilibrium. Can one of you tell me what equilibrium means?
Acceleration 0, sir.
Acceleration 0, net force 0 also you can say. Correct. So all the forces on the block are balanced. One of them, has to be friction, because without friction, the block cannot stay there. So visualize what other forces are acting on it and just balance them. Okay. Opposite forces balance. Pawan, tell me what forces act on the block.
Sir, gravitation,
Tell me the components.
mg sin theta,
Mg sin theta is along the incline or perpendicular to the incline?
along the incline, sir.
Yeah, along the incline, you will have mg sin theta. How much will that be in this case? Mg is 100 sin 37.
$60.
Right. Okay. So a component of its weight, 60 Newton, that is mg sin theta, will be acting along the incline. How much will act perpendicular to the incline?
mg cos theta, sir.
mg calculate చేసి చెప్పు.
80, sir.
80 newtons. Okay. Will be acting perpendicular to the incline. Any other forces that act on the block?
No, sir.
Who said no?
Oh, like the friction is also there.
That's all. Okay, friction should be there,
The
otherwise it will slide down, we know.
normal also.
Okay. And friction we are yet to calculate, we'll do that. And normal force acts like this, perpendicular to the surface of contact. Fine. Now clearly the forces either have components along the incline or have components perpendicular to the incline. There is no force, like none of these forces has both components. Okay, which makes the question very easy to solve. Which force is friction balancing? For the block to be in equilibrium, which force is friction balancing?
60 newtons, sir.
60 newtons, the weight component along the incline. So friction must be 60 newtons. That's all. How much should the normal force be? No, okay, not much to think also. Normal force should be 80 newtons. Now we need the minimum coefficient of friction. Okay, understand how to approach such questions. Now what we found out is friction is 60 Newton here. That is the friction that is acting. Okay. Now the amount of friction acting in a particular case should definitely be less than or equal to the maximum friction that can act. It can't be more than the maximum. No, then the word maximum won't have any meaning. Okay. So we can say that the friction acting in a particular situation is less than, like we know that much friction is acting for sure. Okay. So that must be less than or equal to maximum friction is given by mu s into n. Okay. Therefore, 60 should be less than or equal to mu s into normal force is 80. Okay, I think Saket, you made a mistake. You took normal force as 100. Normal force is not always equal to mg. Okay, so mu s becomes 60 by 80. That is 3 divided by 4. Or okay, let's not forget the inequality symbol. Just send 80 that side. You get mu s greater than or equal to 60 by 80. That is 3 by 4. Therefore, for that much friction to act, for the block to be in equilibrium, mu s should be greater than or equal to 3 by 4. 3 by 4 is 0.75. That means it should at least be 0.75. Anything more than that also is fine. Friction will be sufficient. But if coefficient of static friction is less than 0.75, the block would not have been able to stay there. That is what it means. Is this clear to all of you? Any questions? So minimum required coefficient of static friction is 0.75. Fine. Next question. In the worksheet, I had given you some interesting questions actually, but this time nobody sent responses to the worksheet. Anyway, consider this situation itself again. Suppose it's a rough surface and the coefficient of static friction here is 0.5 this time. Assume the mass of the block is some 5 kg. Okay. Now consider these two cases, all of you. Case 1 is applying force on the block this way, horizontally, parallel to the ground. Okay, that is case 1. And case 2 is applying force on the block at an angle like this. Just from your everyday experience or based on your intuition, you tell, in which case do you think it will take lesser effort to move the block? We want to slide the block on the surface. In which case do you think it will be easier?
The first one.
Okay, Rishi is saying first one. We'll see, we'll discuss. Others also, I want answers from all of you. You can type in chat if you want, but make it quick. The question is, in which case will the required force be less? The effort we need to put, in which case will it be less? Okay, I got two more answers. One saying first case, one saying second case, one more saying first case. Okay. Fine. Listen, all of you. See, the correct answer would be that it cannot be determined. Why? I mean, some of you thought it's the first case. How are you sure that the first case would definitely require lesser effort than the second case? No, just to know what factors you considered. How did you say that like if you apply a force horizontally, it will be easier to slide it? Okay, fine. Maybe you just chose one of the options. Let it be. But now we have to, like, now that we learned some physics, we can prove, like, we can actually calculate in which case the required effort would be less. Okay, so let's take two different situations. First case, let it be the horizontal force F itself. Let's call it as fine, F1. Tell me directly how much minimum force F1 should be applied for the block to slide.
25 newtons, sir.
25 newtons. Okay. So we need to consider other forces acting first. Its weight 50 Newton will be acting. There will be a normal force acting this way. In this case, how much will the normal force be? It will be 50 Newtons itself. Okay, because there is no other force in the vertical direction. Normal force has to balance the weight. Okay. Now to slide this block, F1 should be greater than or equal to mu s n. N is 50, mu s is 0.5, 0.25 into 50. This becomes 25. So the force F1 should be greater than or equal to 25 newtons. So sliding it horizontally, I mean sliding it by pulling it horizontally would require an effort of 25 newtons. Fine. Let us now consider the other case where we apply force at an angle. Just a moment. Let us assign some angle also, maybe 37 degrees. Just some random angle I'm taking. I'm not saying this is the final answer. Depending on this angle, we can tell the answer. We need to think of other angles as well. Okay, we need to generalize it. We'll do that. Now its weight 50 Newton will be acting. There will be a normal force acting. And there is this force F2 that we are applying. First of all, tell me which force is trying to make the block slide? Because the question is about what effort, how much effort we need to put to start sliding the block. Which force is trying to make the block slide?
Yes, sir.
Is all of F2 involved in making the block slide? Sliding has to happen parallel to the surface. No, F2 is not acting parallel to the surface. So complete F2 is not trying to make the block slide. There is only a component of F2 trying to make it slide. How to write this component? The force is
F2
F2.
cos 37, sir.
F2 cos 37. Cos 37 is 4 by 5. So 4 F2 by 5 is what is trying to make the block slide. Is this point clear to all of you? Yeah, I mean the actual force trying to make it slide is F2 only, but now we have to write equations, no? So what is actually acting parallel to the surface is only this much. The complete force is not parallel to the surface. Okay. So can we say that to start sliding in this case, 4F2 by 5, that's the force trying to make it slide, no? Can we say that this should be more than or equal to mu s is 0.5, and can we say normal is 50 here and write the equation this way? Is this okay?
Yes, sir.
Others,
No,
what do you
sir.
think? Vanilla, why not?
You should also consider the vertical component of F2.
In this case, normal force will not be 50 newtons. Okay. Why will it not be 50? The question why it should be 50. Normal force acts to prevent the block from going down. You should first see what other forces are there in the vertical direction. No, F2 now has a vertical component here. Okay, it will be F2 sine 37. Sine 37 is 3 by 5. So this becomes 3F2 divided by 5. Fine. Now normal force will adjust accordingly. The force pulling the block down is 50 newtons. There is a force trying to support it already, 3F2 by 5. Then the normal force will only be, like for the block to not lose contact with the ground, you can say normal force plus the 3F2 by 5 are balancing the weight of the block. So this time normal force will only be 50 minus 3F2 by 5. It won't be 50 this time. Okay, so effectively what you are doing is you are reducing the normal force by pulling the block at an angle. And if normal force reduces, what happens to limiting friction? Can one of you tell? I'm not asking the exact value, but generally if normal force, if the pressing force between two surfaces decreases, what happens to the maximum friction between them?
Decreases, sir.
It will decrease. Okay. So in this case, we are effectively making friction lesser. So it may be easier to slide. Now, just because you made friction less doesn't mean it will definitely be easy to slide. Because in this case, complete force is not involved in sliding. So there is there's an advantage and a disadvantage also. Compared to applying the force horizontally. If you apply force at an angle like this, you are reducing the normal force. So you are bringing the friction down. But when you apply force at an angle like this, all the force you put is not involved in sliding the block. Only a component of it is getting involved. So you will have to do the calculation and check whether this is better, this is easier, or the previous case is easier. Let us do the calculation now. Sliding force should be greater than or equal to limiting friction. Okay. Write this equation on your own, all of you. Force trying to slide the block should be greater than or equal to μs multiplied with the normal force. So I want you all to actually substitute those forces in this and calculate how much F2 should be. Try this. I'll give you 2 minutes. Any answer? Okay, tell me, let us substitute these values. Saket, unmute and tell. What is the force trying to slide the block?
4F2 by 5.
Okay, let's just call it F for now. 4F by 5 should be greater than or equal to coefficient of static friction is 0.5. How much is the normal force?
50 minus 3F by 5.
50 minus 3F by 5. That's all. Simple calculation. You'll have to keep the F terms on one side. 0.5 is like 1 by 2. So 4F or 1 by 2, you send the 2 this side, it becomes 8F by 5. Greater than or equal to, that 1 by 2 has been sent to the other side. So remaining will be as it is, 50 minus 3F by 5. Send that minus 3F by 5 to this side, it becomes plus 3F by 5. 8 plus 3, 11F by 5. greater than or equal to 50 newtons. That means F, that is F2, should be greater than or equal to 5 into 50 is 250 divided by 11. Okay. 250 by 11, is it more than 25? Because in the previous case, when you dragged it horizontally, the required effort was at least 25 newtons. Now the required effort is at least 250 by 11. Is this more than 25 or less than 25? We just need to know that much.
Less than, sir.
It is less than 25 because 250 by 10 itself is 25. 250 by 11 will be less than 25 newtons. So in which case is it easier to slide the block? First case or second case?
Second case.
Second case. Okay. But see, we took an angle 37 degrees and found out that in the second case, it is becoming easier. Actually, what is happening? This upward component is reducing the normal force and this horizontal component is dragging the block. Okay. Imagine what happens if we increase the angle too much. Okay, if you make that angle too much, just a moment, I'll copy this diagram. If we increase the angle too much, the vertical component will increase, horizontal component will decrease. So it could, like suppose you apply the force this way, there will be a very small horizontal component which can drag the block. That may make it a disadvantage. We cannot say. Okay. So suppose the angle is theta. Generally, let's say the angle is theta. Then the component sliding the block will be F cos theta. And the component trying to lift the block up will be F sin theta. We are decreasing the normal force, okay. But the force which is trying to slide the block is also getting decreased. Very rapidly it will decrease. So you need to actually check whether it's always whether increasing the angle continuously is an advantage or not. Let's take one angle just to check in one case. We'll try 60 degrees. I'll tell you the value of cos 60, sin 60 and all if you want. Suppose the force F is now being applied at an angle of 60 degrees. Solve this quickly, all of you. The horizontal component obviously is F cos 60. Cos 60 is 1 by 2. So the horizontal component will be F by 2. Vertical component is F sin 60. Sin 60 is root 3 by 2. How much is root 3? Anyone?
$1.7.
1.732. Okay. So root 3 by 2 would be 1.66. Sorry, not one. Sorry, what am I saying? 0.86. Okay. So F root 3 by 2, that is one force. Okay. Now I won't show F because we have considered the components. You can keep it as root 3 itself if you want. Do the calculation. Finally, we'll substitute root 3 as 1.732 and check how much is the minimum force needed. Do this quickly, all of you. The equation is the same. Sliding force greater than or equal to mu s into normal force. Any answer in terms of root 3? Okay, first tell me, how much will the normal force now be? Not exact value, but how to express normal force.
50 minus f root 3 by 2, sir.
50 minus f root 3 by 2. That's the normal force. So writing that in the equation, sliding force is f by 2 should be greater than or equal to mu s is 0.5. I'll take it as 1 by 2. Normal force is 50 minus f by 2. Okay. Send the 2 that side. It becomes 2f by 2. Wait. 50 minus f root 3 by 2. Send the 2 that side. It becomes 2f by 2 greater than or equal to 50 minus f root 3 by 2. Now send the f root 3 by 2 that side. It becomes, if you take f common or f by 2 common, 1, 2 is there. And now the root 3 comes to that side, greater than or equal to 50. Send to that side now 100. So f must be greater than or equal to 100 by 2 plus root 3. Root 3 is 1.732. So 2 plus that will become 3.732. Let me check. But okay, we don't even have to check. Tell me, is this more than 25 or less than 25? 100 by what number is 25?
4, sir.
100 by 4 is 25. Now you are dividing 100 by a number less than 4. If you are dividing it by a number less than 4, then this will definitely be more than 25 newtons. Okay, this is what I was telling you about. If you increase the angle too much, then it may require more effort. Fine, because in this case at 60-degree angle, we are seeing that it requires more than 25 newtons to slide the block. Okay, applying it horizontally would have been better. So now comes the actual point. As we are changing the angle, the effort required to slide the block is changing. Okay, when the angle was 0 degrees, that is when the block was pulled horizontally, effort required was 25. But as we increased the angle, the required effort decreased, because we know that at 37 degrees it required lesser amount of force to slide the block. Okay, 250 by 11 only at 37 degrees. But if you go on changing the angle, at some point it again starts to increase. The effort needed to move the block, slide the block, again starts to increase. Okay, so now comes the actual point. What is the exact angle at which the required effort is the least? 37 also we cannot say. I randomly gave 37 degrees. Maybe if you take 45, you will find that it is even lesser than 250 by 11. It could happen. Okay, so 37 was a random angle just to check if it requires more effort or less effort. We found it requires lesser effort. Maybe at 38 degrees it requires even lesser effort. We don't know. Okay, so now the question is to find out the exact angle at which the required effort would be the least, and also how much is that least required effort. That's the question. Now let us work on it. So it's like a general question. What is the minimum force required to slide the block? So if they ask you a question like this without specifying how the force is to be applied, then it is up to you to consider all possibilities. Okay, see what are all the possibilities now, starting from applying the force horizontally to applying the force vertically. Okay, you keep on changing the angle. At some angle, we don't know how much that is, but at some angle, the effort required would be minimum. That angle is what you need to find out, and that minimum effort is what you need to find out. If we know angle, we could have told how much effort is needed, because for 37 we derived the result, for 60 also we derived the result. Once we know angle, we can tell how much effort is needed. Without knowing angle, how can we find out the effort? This is where you write general equations. Okay, assume some angle theta, write equations based on theta. Okay, are you all following me? Did you all understand what we need to calculate now? If any of you have a doubt, you can ask. Okay, so what is the angle and what is the minimum force needed to slide the block and at which angle it should be applied. Okay. Let's say we are applying a force F like this at an angle theta. And let us make it even more general. Let's say the mass is m. Coefficient of static friction is mu. Instead of writing mu s, I'm only writing mu, okay, just to make it simpler. One of you quickly tell me what other forces act on this block and how much are they? Just tell me the other forces acting on this block.
Normal and
Sir.
gravitational force.
Its weight mg would be acting, and it's in contact with the ground, so normal force would be acting. Normal force also, I'll just call it N. And obviously there will be friction acting. The force which is trying to make the block slide has to overcome friction. Okay. Tell me the expression for normal force now.
N plus F sin theta, sir.
I asked you the expression for N. Okay, or N plus F sin theta balances what?
Sir, sliding force by coefficient.
No. See, there will be F sin theta acting vertically, and there will be a component F cos theta acting horizontally. So now you don't need to consider the original force F. So the block has to slide along the surface. It should not lose contact with it. So vertically it should be in equilibrium. For vertical equilibrium, the sum of normal and F sin theta should balance mg. So N plus F sin theta becomes mg. So N becomes mg minus F sin theta this time. Okay. Previously also that is what we had written. N is 50 minus F root 3 by 2. 50 was mg there. Okay. So we are doing the same thing here. Vertical equilibrium will give us the equation for, or will give us the magnitude of normal force. Okay. Now you all tell me, what is the inequality that we need to write? Like if you want to find out the minimum force required to slide the block, how will you write the equation? Which force should be greater than which force to slide the block? That's my question.
Sir, the sliding force.
How much is it this time?
F cos theta, sir.
So for sliding the block, F cos theta should be greater than or equal to mu into normal force. Normal force now is mg minus F sin theta. That's the condition that you get. Now let us keep the F terms on one side. You get F cos theta. On the other side, you have minus mu F. Okay, let me simplify this. Mu mg minus mu F sin theta. Okay. Now keep the F terms on one side. You get cos theta plus mu sin theta greater than or equal to mu mg. Okay. Therefore, the force needed to slide the block is greater than or equal to mu mg divided by that term cos theta plus mu sin theta. This time numbers were not given to you. Numerical values of theta, mu and m were not given to you. Okay. So anyway, this is the expression we get for the required force to slide the block. But this time, you were also asked to find out at what angle that minimum effort would be needed. So you don't know F. You don't know the minimum effort F. You don't even know the angle theta to calculate that minimum effort. You only know coefficient of friction, mass of the block, and acceleration due to gravity. Had theta been known, you could have calculated F. That is what we did in the last 3 questions. Horizontal, 37 degrees, 60 degrees. Based on angle, we were able to tell F. But now you see that I mean, now this is a general expression. For different values of theta, you'll be getting different values of the force. What is it that we want? We want the particular value of theta where the force will be minimum, and we want to know what is that minimum force also. Okay. So if you observe, there is a variable on the right hand side, theta. And based on theta, the minimum required force will change. And theta is only in the denominator of the right hand side. So when this term is maximum, the total force needed would be minimum. Is this clear to all of you or not? On the right hand side, the denominator is a variable. Depending on theta, its value can change. So when the denominator on the right hand side is maximum, highest, then the whole fraction will be the least. That means the force needed will be the least. Okay. Now the question is mathematical. How much is the maximum value of cos theta plus mu sin theta for any angle theta? Do any of you know the maximum value of a sin theta plus b cos theta? Maximum value of a sin theta plus b cos theta. Generally, if theta is a variable, if you are allowed to put whichever theta you want to put, do you know what is the maximum of this? Okay.
Root a square plus b square, sir.
Correct. Root of a square plus b square. Fine. For now, we will use the answer directly. In the next worksheet, I'll give you steps how to find out the maximum value of this term, a sin theta plus b cos theta. Okay. It's all mathematics. Differentiation you'll have to use. Some of you were there when I taught differentiation. You'll need to use, like, if y is equal to some function of x and you want the maximum value of y, what you do, you differentiate it and equate it to 0. Okay, same thing. If you want the maximum of a sin theta plus b cos theta, you differentiate that whole thing with respect to theta and equate it to 0. Okay, anyway, it's a slightly lengthy process. But remember, maximum value of some constant a multiplied with sin theta plus some constant b multiplied with cos theta is root of a square plus b square. So here, see, sin theta's coefficient is mu. So it's like mu is a now. And cos theta's coefficient, we don't see any coefficient, means the coefficient is how much? If there's no term written before cos theta, what coefficient does it have?
1, sir.
1. Okay. So in place of a, we have mu, and in place of b, we have 1. Then the maximum value of this becomes root of mu square plus 1. A square plus b square. Mu square plus 1. So the maximum value of the denominator is mu square plus 1. Therefore, to slide the block, the minimum needed force is mu mg divided by under root mu square plus 1. If we apply this to the question that we solved, in the question that we solved, mu was 0.5, mass of the block was 5 kg, acceleration due to gravity is 10, divided by under root mu square, 0.5 whole square is 0.25 plus 1 becomes 1.25. Numerator 15 to 0.5 is 25. Divide by under root 1.25. Let me calculate this quickly, but you just recollect the steps that we went through. The answer to this happens to be 22.36. Okay. So this block that was there, this 5 kg block on the ground, the minimum needed effort to slide this block is 22.36 newtons. Now at what angle that should be, that is a separate question. Okay, that you will be able to solve in the worksheet. Like when you learn how to find maximum value of a sin theta plus b cos theta, in that process itself, you will get an expression for the angle which gives you the maximum value of this expression. Okay, at that angle you apply the forces, you will only need 22.36 newtons. Okay, so any questions? Fine. So basically the problem was we didn't know at what angle the force should be applied and how much force should be applied. So both f and theta were variables. So we got f in terms of theta and we found out the minimum value of f using calculus. Okay, actually we didn't do that, but calculus will tell you that the maximum value of a sin theta plus b cos theta is root of a square plus b square. Okay,
Can you
let's
scroll up 1 second? I just want to go through this stuff.
this part.
No, sir. Like the starting 2 steps.
This.
Yes, sir.
So f cos theta is the force which is trying to slide the block. This is mu and this term is normal force. Okay, so this whole thing becomes limiting friction.
Okay, sir. Okay. Yes, sir. You can scroll down.
Okay. Fine. Let's try another question. Let's say there's a rough horizontal surface and pulley here. Assume a block is placed on that surface. Assume the mass of the block is some 4 kg. Coefficient of static friction, let's say 0.3. Right. There's another block on the other side. Assume the angle made by the rope at this moment is 37 degrees. And this mass is m. Calculate maximum value of m such that the system does not slide. Or, okay, such that the 4 kg block does not slide. Do this, all of you. Solve carefully. What force does a string exert? Someone said something.
Tension, sir.
Tension. Okay. So to whichever block the string is connected, you have to consider tension acting on it. And in which direction does a string exert tension? In which direction does a string exert tension? And it exerts tension or it pulls along its own length. Okay. So tension acts along the length of the string, you must say. Okay, start solving. Okay, I got only one answer as 1.5 kg. We will see. Listen, all of you. See, just look at it as a fresh question. Do you all feel that if we keep on increasing the mass m, at some point the 4 kg will slide or not?
Sir, it will.
It will, okay? But if the mass m is too light and there is friction on that surface, then 4 kg may not slide, okay? So as we increase mass m for one value of m, the 4 kg block will start sliding. So that is what they are asking about. Okay. Now the mass m directly doesn't pull the 4 kg. The condition is to calculate the mass such that the 4 kg does not slide. So think of what is making the 4 kg slide. Can one of you tell me? I'm not asking numerical values, but what is trying to make the 4 kg slide?
Sir, the string, which is like, and also the mass.
The mass is not attached to 4 kg, no?
Sir, P cos theta.
It is the component of tension which makes the 4 kg slide. Of course, tension gets generated due to the mass on the other side, but you can't say mass is making the 4 kg slide. You should say tension. When I say what is making something slide or something move, I'm talking about the force which makes it move, which is trying to make it move. So there will be a tension acting this way on the 4 kg block. That tension will have a component horizontally, T cos 37, that is 4T by 5. That force is what makes the 4 kg move, 4 kg slide. Okay. Now we don't want the 4 kg to slide. That means the sliding force should not become more than what? When will an object not slide? When the sliding force is less than what?
Limiting force.
Limiting
Limiting
friction.
friction,
Limiting friction, correct. So the condition for this problem would be sliding force 4T by 5 should be less than limiting friction, mu s into n. Mu s is 0.3, n we will write. Okay. So using this, we can calculate tension first. And tension depends on the mass on the other side. No, because the weight of that other mass is what is creating tension in the string. Okay. And if 4 kg doesn't slide, will m slide? If 4 kg does not slide, will the mass on the other side move? I should not call it slide. Will the mass on the other side move?
no sir.
It won't. Okay. And the same tension will be acting on it. We are dealing with ideal strings. Okay. Ideal strings are massless, inextensible. Same tension acts everywhere. Okay. Rishi, you tell me the expression for normal force acting on this block.
The normal force, right? Sir, I'm actually not sure.
Okay, tell me what all forces act on the 4 kg block.
Sir, 40 Newton, and then
Its weight 40 Newton will be acting, and
yeah, 4T by 5 and one more, the F sine theta, sir, which will be
in which direction
one
will that
second,
be?
sir. That'll be upwards, like
Upward. Okay, the force is tilted upward, so the component will be upward. T sine 37. Sine 37 is 3 by 5, so 3T by 5. Okay. What other forces act on it?
that's all, sir.
Okay, normal force should be there, friction should be there. So normal force, which is acting upward. What does normal now have to balance? See, normal should prevent the block from going down, right? There is a surface below it. Normal should prevent the block from going into the surface. So to prevent the block from going down, how much normal force is needed now?
40 minus 3t by 5, sir.
Okay. It'll be 40 minus 3t by 5. 40 is trying to pull the block down. 3t by 5 is already acting upward. It is supporting it, no? So the difference is what normal force needs to create, okay, generate. 40 minus 3t by 5. That much normal force is necessary. And along with all these, there will be friction acting. Friction prevents the block from sliding. Okay. So now we will substitute that expression of normal force here. Mu s is 0.3 and normal force is 40 minus 3t by 5. That's all. From this equation, we'll get tension. 4t by 5. 4 by 5 is 0.8. I'll write it directly. Less than 0.3 into 40. 3 into 40 is 120. 0.3 will be 12. Minus 0.3 into 3 by 5. 3 by 5 is 0.6. Multiply that with 0.3, 0.18 t. Anyway, from this equation, you can get t. Okay, but still that doesn't solve the question. You are asked to calculate the mass m for the maximum mass m such that the block does not slide. Now here, you actually get an inequality. You will get t less than some value. That means you know what is the maximum tension which can be generated in the string. And now tell me what generates tension in the string? What creates tension in the string connecting the blocks? Yeah. Why is tension arising in that string at all? Or basically, what is the main force trying to make this system move?
Sir, the mass, the block.
You should say weight of the block. Okay, gravity. Right. So suppose, okay, let's say its weight is mg. Now, if the 4 kg is not sliding, this block also will not be moving. Then tension should be equal to mg. Now you got T less than some number there, right? So you know the maximum tension that can be generated in that rope. And we know T is equal to mg because for this block to be in equilibrium, T has to be equal to mg. Therefore, in place of T, if you write mg, you will get mg less than that number and send g to that side. G is 10. So m less than that value divided by 10. So mass should be less than this. That's the answer. Okay. You fill those blanks, you complete it later. But did you all understand the idea or not? The question was to find out maximum mass m such that the 4 kg does not slide. So just learn how to think. You don't want the 4 kg to slide. So think of what is making the 4 kg slide. Write an equation based on that. Okay, it should not slide. Based on that, we'll write the equation. And then how to connect that to this mass. Tension is what is common between the two blocks. Then the only way you can connect that part and this part of the system is through tension. Okay. For that part to be in equilibrium, for 4 kg to be in equilibrium, sliding force should be less than limiting friction. For mass m to be in equilibrium, tension should be equal to mg. That's all. Connect them, you will get the answer. Is this clear to all of you? Any doubts? And one very important thing you need to keep in mind is normal is not 40 here, it is 40 minus 3t by 5. Okay. Just a moment. If you want, you can complete this. I'll just take 1 minute. Okay. Now consider this. Suppose there is a rough inclined surface. Yeah. Okay, let's say this has an angle of inclination θ1. Consider another rough inclined surface. Assume this one has a greater angle of inclination. Okay, somewhat like this. Or maybe it will be easier to visualize if I put it below this. They both have the same base, but one is taller than the other, so definitely the angle will be different. θ2. Tell me, imagine placing a block on each of those surfaces. On which surface, I should not say on which surface, the nature of surface is the same. Okay. For which angle, θ1 or θ2, is the block more likely to slide? If you just keep the block there and leave it, on which surface is the block, or on which incline is the block more likely to slide? Case 1 or case 2?
Case 2, sir.
Okay, we'll see. Others, what do you say? In which case is it more likely to slide?
So the second one.
Second one. Why?
Sir, because the height is more, right? So
Height is more, so
like I don't know how to explain that. Yes, sir.
okay.
The angle theta is larger.
Because the angle of inclination is more. In the second case, it's more likely to slide. But let us prove it mathematically that if angle increases, the likeliness to slide increases. We'll have to prove that. What makes the block slide? In any case, assume generally the angle is theta. What makes the block slide? Anyone?
So the
Mg
surface.
sin theta, sir.
See, it's not the surface which makes it slide. When I ask what makes it slide, you should tell which force. Okay. As Vanilla said, it is mg sin theta. The component of the block's weight along the incline is what drags the block down. Mg sin theta. What are the other forces acting on it? Fine.
Or mg cos theta, and then
Yeah, the other component of weight mg cos theta will be acting. And because there is a surface of
the
contact, a
mu
normal
also.
force.
Mu.
Mu is not a force. Mu is just a coefficient. It's just a number.
Yeah, yes, sir, yes.
We should say friction. Friction will be acting this way, preventing it from sliding. Okay. Now for the block to start sliding, mg sin theta should be greater than or equal to limiting value of the friction. Okay. So mg sin theta should be greater than or equal to mu s multiplied with n. Can one of you tell me how much is n in this case? Saket, how much is the normal force? Okay, Saket is not there. Aishwarya, how much is the normal force?
Sir, mg cos theta.
It will be balancing mg cos theta. There is no other force which has a component perpendicular to the incline. So like these cases are a little easy. Normal and mg cos theta are perpendicular to the incline. F and mg sin theta are parallel. Perpendicular, parallel, they are at 90 degrees. So they won't have components, they won't interfere with each other. So n is equal to mg cos theta here. Okay. So in place of n, if you write mg cos theta, you can cancel mg on both sides now. And if you send the cos theta this side, sin theta divided by cos theta becomes tan theta greater than or equal to coefficient of static friction. Okay. or you can say theta should be greater than or equal to tan inverse of coefficient of static friction. So this is the minimum angle at which the block slides. Okay, tan inverse of mu s. Till the angle becomes that much with the horizontal, the object is not going to slide. Okay, and basically as you increase this angle, see, you all must be knowing how much is sine 0?
0, sir.
Okay, let us write those values here just for a quick reference. Sine, cos. Sine 0 is 0, cos 0 is 1. Next, sine 30 degrees is 1 by 2. 0. Okay, let's take it 1 by 2. Cos 30 degrees is root 3 by 2, greater. Next, at 45 degrees, we know they become equal. 1 by root 2 and 1 by root 2. Then at 60 degrees, sine dominates. Root 3 by 2. Cos becomes lesser, 1 by 2. And at 90 degrees, it's completely sine. Sine is 1, cos is 0. Okay, so as we increase this angle, what happens is mg sine theta goes on increasing. When you increase theta, sine theta increases, no? So mg sine theta, this component of weight pulling it down the incline increases. And on the other side, limiting friction. Limiting friction depends on normal force. Normal force is mg cos theta. As angle increases, cos theta decreases. Okay, so mg cos theta will decrease, as a result of which friction will decrease. So as the angle becomes greater and greater, sliding force is becoming stronger, friction is becoming weaker. That is why the tendency to slide increases as you increase the angle. And at this particular angle, sliding will begin. I mean, you can use this angle both ways. You can say this is the maximum angle for which the block will not slide. You can also say it is the minimum angle for which it will start sliding. It's the same, it's that limit. Okay, and this angle is called, do any of you know the name? The angle of inclination at which an object placed on it just starts to slide. Okay, it's called angle of repose. Okay, name is not very important, but it will help us in solving problems. If there is an object placed on an incline, you can quickly decide whether it's going to slide or not by comparing these values. In fact, we won't even be using it in this form. We'll be using it in this form. Just see how much is tan theta and see how much is the coefficient of static friction. If tan theta is more than static friction, coefficient of static friction, it means the angle is too much and the object cannot stay there on its own. It needs extra support. If tan theta is less than mu s, it means the object can stay there. You keep it at rest, it can stay at rest. Okay, so in problem solving, it will help. If you want to visualize what will happen to a system, this will help. Okay, let's quickly solve one problem based on this. Last question for today. Assume coefficient of static friction is given, say 0.5, and this angle is given as 37 degrees. Mass of the block is 2 kg. Tell me, if you keep the block on the surface there, inclined surface, will it stay there or will it slide? We are just gently placing it there and leaving. Can it stay there or does it slide? What are the two terms you need to compare to check whether an object slides on an incline or not?
Tan theta and mu s, sir.
So this is the condition. If tan theta is greater than or equal to mu s or not is what you need to check. Fine. Okay, I think some of you are still slow with tan, sine, cos and all, especially for 37 and 53 degrees. How much? Okay, you need to compare tan theta and coefficient of static friction. Coefficient of static friction is 0.5, that is 1 by 2. How much is tan 37 degrees? Anyone?
3 by 4, sir.
3 by 4. Sine 37 is 3 by 5. Cos 37 is 4 by 5. So dividing them, it becomes 3 by 4. 3 by 4 is 0.75. Obviously, 0.75 is greater than 0.5. Tan theta is more than mu s. What does that mean? Does it mean the block will slide or will it stay there?
It will slide, sir.
It will slide. Tan theta is more than mu s means the angle is too much. Okay. So at this angle 37 degrees, the block cannot stay there. It will slide. Then you can prevent it from sliding by giving it some support. Okay. You can apply a force like this up the incline. You can apply some extra force up the incline. Okay. Let me indicate it on the other side itself. You can apply a force like this and prevent the block from sliding. Calculate the force that is needed. We are not applying at any angle or anything. We are applying parallel to the incline itself. I'll draw a better arrow. But you understand the question, no? Calculate the minimum force needed to prevent the block from sliding down. So in exams, they will directly ask you what is the minimum force needed to prevent the block from sliding. You will have to do this check on your own. You should check whether, first of all, the block has a tendency to slide or not. Because it doesn't. If it doesn't have a tendency to slide, you don't even need to apply any force. Okay. Try this, all of you. I'll give you all 2 minutes. Okay, I got one answer as 4 newtons. Let's see. Pawan, can you tell how you're trying to solve this problem?
Sir, frictional force 12 newtons an hour.
Tell me the other forces first. How much are the weight components along the incline?
mg sin theta, sir.
ఎంత అవుతుంది చెప్పు. Formula is correct, only mg sin theta, but how much is it?
12 newtons, sir.
Okay, 20 sin 37, 12 newtons will be acting that way. Mg cos theta will be 16. Normal force? Pawan, how much is the normal force?
Sir, 16 newton.
That 16 has to be balanced by the normal force. So normal is 16 newtons. And mu s is given 0.5. See, we want to put minimum effort to prevent the block from sliding. Fine. Friction is already trying to prevent it from sliding, but it's not sufficient. Now, you just need to give the bare minimum such that it doesn't slide. Means friction should be putting its maximum effort. You want to put minimum effort to prevent sliding. Means friction should put maximum effort to prevent sliding. That means limiting friction must be acting. Okay, so friction is already trying its best. In that case, the effort you need to put will be the least. Okay, how to calculate limiting friction? Mu s into n. So limiting friction Mu s is 0.5, normal force is 16, so that is 8 newtons. 8 Newton limiting friction is already acting up the incline. So how much extra effort do you need to put to prevent it from going down? Pawan, what is your answer?
Sir, 12 అన్నా sir.
Why will it be
4
12?
newtons sir.
4
అంటే
newtons.
స్టార్టింగ్ లో అప్పుడు చెప్పండి.
Okay. So friction already 8 Newton is acting. So you only need to put 4 newtons to prevent the block from sliding. So see, understand how we are approaching the problem. The problem was to find out the limiting, not limiting. Problem was to find out the minimum force required to prevent the block from sliding down. So first you consider all the other forces. Any problem in mechanics, no, it starts with considering the forces acting on an object. So whatever forces you know, you indicate them, write their magnitudes directly. And then the unknown forces. In this case, friction is also an unknown force. See, for friction, for limiting friction, there is a formula, but that much friction need not always act. Only how much is necessary, that much will act. In this question, they are asking how much minimum effort we need to put. If you are putting minimum effort, friction should be putting maximum effort. That is how you can say that friction is 8 newtons. Okay, then you calculate the unknown force as 4 newtons. Okay, fine. We'll stop it here for today. It's been too long. So tomorrow I'll send you a worksheet with the derivation of that. In that you'll be able to solve it on your own. You can find out the maximum and minimum of a sin theta plus b cos theta, and some more questions based on this. In the last worksheet also, there were some questions based on friction and all. Okay, solve these questions. Okay, thank you all. I'm closing the session here.